Hello, so let's try this problem from chapter number 4. It says when salmon head upstream to spawn, they may encounter a waterfall. If the water is not moving too fast, the salmon can swim right up through the falling water. Otherwise, the salmon jump out of the water to get to a place in the waterfall where the water is not falling so fast. When humans build dams that interrupt the usual route, followed by the salmon, artificial fish ladders must be built. They consist of a series of small waterfalls with still pools of water in between them, like this picture. Suppose the salmon can swim at 8 meters per second with respect to the water. What is the maximum height of the waterfall up which the salmon can swim without having to jump? So, for this problem, we'll use the kinematic equation. So let's try this equation in our x coordinates, which is f of vx square minus v of ix square is equals to 2 times ax and delta x. If we use the same equation in the y components, then this will be v of f of y square minus v of iy square 2 times ay delta y. So the equation is same, but it's just like instead of x coordinate we are using the y coordinates. Now again v of f of y square minus 0, since the initial velocity is 0, and acceleration in this case will be g, negative g, and delta y will be h. So in this case we can say that h is negative of delta y. So this, suppose, is delta y, it can become 2gh. So now our equation is v of fy square is equals to 2 times of gh, and from this we can say that h is equals to v of fy square divided by 2 times of g, and this is what we need to find, the maximum height h. So v of fy is given to us, this is 8 meters per second, so square of that 2 times 9.8 meter per second square. So from this whole calculation h will come out to be 3.27 meter. So this is the height in this case. Now, but it says that in a if a waterfall is 3.38 meter high, how high must the salmon jump to get to the water through which it can swim? Assume that they jump straight up. Now, since the salmon can only swim through water that has fallen 3.27, so we found h is equals to 3.27 meters from our previous part. So the salmon must jump, in this case this should be, so 3.38 meter minus 3.27 that we calculated, this should be 0.110 meter. Now for the third part, if a waterfall is 3.38 meter high, what initial speed must the salmon have to jump to the height to get to water through which it can swim? Assume that they jump straight up again. So now again we are going to use our equation, that v of fy square v of iy square is equals to 2 times g, or directly we can use 2 times of g of h. Now v of fy square, this is 0, this can directly be taken equals to 2 of gh, and v of f of y is under root of 2 times of the gh. Just plug in the numbers. 2 times g is 9.8 meter per second square. H, we are going to use this 0.110. So from this, v of f of y will be 1.47 meter per second. So this is for this part. Now next we have for a 1 meter high waterfall, how fast will the salmon be swimming with respect to the ground when it starts swimming up the waterfall? So now let us consider the motion of salmon, the motion of salmon and water relative to the ground. So our equation will be f of salmon ground on y, the salmon water on y, plus water ground with y. So this whole equation will become v of salmon water with y negative under root of 2g h, and this speed is 8 meter per second, negative 2 times 9.8 into 1 meter is the h given to us. So from this s of g of y, when you're gonna substitute these values in your calculator, you will get this equals to 3.573 meter per second. So this is the velocity. Thank you.